Hey everyone, Mr. Fransky here. Today we're going to be talking more about being mathy and doing math modeling here. So this time students will be able to express mathematical sentences and do mixing problems. This should be a little bit shorter than the last one, I'm hoping. So key vocab, mathematical expression, math modeling, and mixing problem. So math modeling we talked about a little bit last time, mathematical expressions as well. This time we're going to go a little bit deeper with mathematical expressions. So given these sentences, we're going to write these as a mathematical expression. So I would try with an actual number and then try to substitute in a variable. So let's do the first one together. 2 more than 3 times a number. So I always kind of start with the innermost thing, 3 times a number. So think about that as 3x. And then it's 2 more than that. Well, I just add 2. That's what I'm looking for. So 2 more than 3 times a number, right? So like 2 more than 3 times 4, you do 3 times 4 first, then you add the 2. So if you want to try these on your own, you can, and then we'll try them together. Let's try this one. 3 times 2 more than a number. So 3 times, so this time the 2 more than a number is happening first. 2 more than a number. So 3 times 2 more than a number. There you go. Next up, we got 8 less than half a number. So half a number, and it's 8 less. So we subtract 8. There you go. Product. Product means multiplication. So we're going to have 2 things multiplied together. 5 less than a number, that's x minus 5, and 4 more than the same number. There you go, x minus 5, x plus 4. 1/3 of 3 less than a number. 1/3 of 3 less than a number. There you go. That's all there is to it. So hopefully this wasn't too tough. All right, mixing problems. So mixing problems are something that people often struggle with, and I'm going to try to give you a procedure that you'll be able to follow to do these every time. So this is also just kind of a thing where you have to think conceptually and try to create a mathematical situation out of it. You want 10 liters of a 15% solution. You only have 10% solution and 30% solution. How much of each should you combine? So let's pretend this is something like, I don't know, Kool-Aid maybe. Okay, could be anything. Could be like an alcohol substance. Could be, I don't know, what else you use stuff like this for. Some kind of chemical. I don't know. So anyway, you want 10 liters of 15% solution. You only have 10% and 30%. How much of each you combine? So this kind of makes sense to me, right? You have 10, which is going to make it weak. You have 30, which is going to make it strong. But there should be somewhere you can mix these together to make a 15% solution. So I'm going to take you through this procedure. First thing I always do is write down what you know, the amount of each percent and the total. You'll have 2 variables. So somewhere in here I'm going to have something I don't know. Okay, so the way I usually do this is I say I have, in this case, I don't know how many liters I have of 10% solution. So I have X liters of 10%. I also don't know how many liters of 30% I have. So let's say I have Y liters of 30%. I know the final though. So my total, what I want for my total is I'm going to have 10 liters of 15%. Okay, because that's what they want me to achieve. Now next, I'm going to make 2 equations, the total amount and the stuff equations. So the total isn't too bad. I know that X liters plus Y liters, that's not right, liters, so it's X plus Y. What does that have to equal? Well, I want a total of 10 liters, right? So X plus Y better equal 10. And then I have my stuff. So think about it this way. Let's say that X was 100. If I have 100 liters of 10% solution, how much of that 100 liters is actually the stuff? Well, if it's 10% of 100, I think that should be 10, right? And you get that by doing 0.1 times 100. So I can multiply the percentage by the number of liters, and that'll tell me how much actual stuff I have. So in this case, I'm going to do 0.1 times x. So 0.1 times x, right? Because that'll tell me exactly how much stuff I'm getting out of that 10% solution. Then if I add to that the amount of the stuff in the y, which is 0.3 times y, because y is the number of liters, it's 30% solution. It should be 15% of the 10 liters at the end. Because this tells me exactly how much stuff is in the 2 combined parts and how much stuff is in it at the end. Cool. All right, now you're going to make your life easier. So that stuff equation, I don't like those 0.1s and 0.3s. I'm going to multiply both sides by 100 to get rid of all those decimals. So if I multiply both sides of this by 100, remember when you do that, you don't have to like distribute to the 0.1 and the x. You can just choose which order you multiply them. So 100 times 0.1x is 10x plus this would be 30y is equal to, and it looks like 15 times 10, that's 150. Again, you don't multiply the 100 by the 10 and the 0.15. You multiply them one at a time. So 100 times 0.15 is 15 times 10, 150. Now what we're going to do is we're going to solve our system. So we have x plus y has got to equal 10. And we also have 10x plus 30y equals 150. Now you could get rid of some of these zeros if you wanted to. In fact, let's do that. So if we divide both sides here by 10, we have x plus 3y equals 15. And now if we subtract, let's call this equation 1 and this equation 2 and this equation 3. If we subtract equation 1 from equation 3, the x's will cancel. We'll have 3 minus 2y, sorry, y is 2y. 2y equals, looks like it's 5. So it looks like y is 2.5. And then it's easy to get x, so just back solve right here. X is 7.5. So you put 2.5 liters of the 30% and 7.5 liters of the 10%. You're going to end up with 10 liters of 15% solution. Now, it's always good to think about this. It makes sense to me that we need more of the 10%. Why? Because 15 is so close to 10. If we used a lot of the 30% solution, that's going to bring that total up more closer and closer to 30. Nice. All right, let's try another one. How many gallons of 14% solution should be mixed with 20 gallons of 50% solution to make a 22% solution? So first of all, what do we know? Well, we know, sorry, let's see. So how many gallons of 14% solution? So x liters of 14% should mix with 20 gallons. Oh, they told us that. So we have 20, sorry, not liters, should be gallons. So 20 gallons of 50% solution. And they want it to be a 20% or 22% solution. So at the end, I'm going to have 22%. And it looks like that's where my other variable is, y liters, it's called, or y gallons. Okay, if we're on y gallons at 22%, then the numbers should work out here. So let's do our stuff equation and our total. Doesn't matter what order you do that. Total is usually easier, so x plus 20 has got to equal y. So as you can see, there's always two things we don't know. Now for the stuff equation, I'll have 0.14x plus, what is that, 0.50, so 0.5 times 20 is going to be equal to 0.22y. Yep. Let's make our life easier by multiplying that by 100, so we have 14x plus 50. Sorry, multiplying that by 100. Yes. So we'll have 14x, yep, that's right, plus 50 times 20 is 500,000. Let's see here. Hold up. 100 times 5 is 50. 50 times 20 is 1,000. Gosh, come on, Fransky. So we have 1,000 equal to 0.22y, so we multiply it by 100, we have 22y. Okay? And the other one, we have x plus 20 equals y. This time I'm going to do some substitution. So if I subtract 20 from both sides, I have x equals y minus 20. So I'm going to put that right here where the x is. So I have 14 times y minus 20 plus 1,000 equal to 22y. Okay, so now we distribute. So we have 14y minus 14 times 20 is 280 plus 1,000 equal to 22y. Now let's subtract. So we subtract 14y from both sides. That gives us 8y. And on the left, let's see, we have 100 minus 280. That's 8, 720. That works nicely. Divide by 8y is, what is that, 90? Cool. So we need a lot of that to bring it down to 22%, which again makes sense to me because we need to make it a lot weaker than 50%. So we have 90 gallons of the y in order to, 90 is our final. What am I talking about? 90 is our final. So we've got to actually make sure we answer the question. So 90 is our final. That means that x must be 70. So 70 gallons is going to be added to 20 to make a total of 90 gallons of 22% solution. Nice. Now, like I said before, this is a problem. These are problems that people often struggle with, and I tell people do this all the time, to write your own problems. Mixing problems are like the easiest problems to write. They're kind of challenging to solve, but if you trade with a friend, it can be kind of cool. So one thing just to remember, your final value should be between the two that you pick. So if I pick like 10% and 80%, Can I make a 90% solution out of those two? I don't think I can, because 10% is going to bring the 80 down, 80 is going to bring the 10% up. There's just no in between. Okay, so make sure you pick something in between, and then you only have two variables. So only two unknowns, we call them. Because if there's more than two unknowns, then you're going to need more equations to be able to solve. Kind of cool, though. All right, that's all I've got for you today. Love you guys. That's why I'm here. Have a good one.